Number 35. Given the parabola, state the following and then graph. Okay, so let's get this in parabola form, in vertex form, so we can actually see what the vertex is. So I'm going to write this y squared minus 10y. Now I'm going to leave a box because we want to complete the square here. And then I'm going to subtract, here, let me show this here. I'm going to go ahead and subtract 8x and subtract 1 from this other side over here. So minus 8x minus 1. So this is going to equal that minus 8x minus 1. We just moved these two to the other side. Okay. So to complete the square here, we take half of the b value, which is negative 5, and square it. So that's positive 25. And of course, whatever you do on one side, you have to do on the other. We add that box. Now we can create a perfect square with this. Y, what's half of the b value? Negative 5 squared equals negative 8x plus 24. If you notice here, we can also factor this, which should usually happen, so that we can get it into vertex form. So this stays the same. We can take out a negative 8. That's going to, negative 8. That's going to leave x minus 3. So now this is in vertex form here. So we can see that our vertex is at 3, 5. So we can go ahead and label that answer. So for part A, the vertex is at 3, 5. Now that we've have it in vertex form. Okay, next, focus. The focus is found by taking this value and setting it equal to, so 4p is what we call it, equals negative 8. This value here is equivalent to 4p is what we call it, so, or is what whoever thought of this called it. So we solve for p. P equals negative 2. So that tells us the focal length for a parabola. So that tells me that I'm going to be going left 2 from my vertex. So my focus, I'm only going to have one because it's just a parabola, is going to be 2 to the left of this parabola. And now, because just as a quick review, because this has y squared, I know it opens to the left. All right. So the focus is going to be to the left 2 of the x-coordinate because I know it's on the x-axis. So it's going to be located at 1, 5. All right. Now the axis of symmetry. The axis of symmetry is located at the vertex. So it may help if we go ahead and graph this. Let's go ahead and do that when we finish finding these things. Okay, so our center is at 1, 2, 3. 1, 2, 3, 4, 5. I'm sorry, our vertex, not our center. All right. This p-value also tells you the distance of the directrix. So we know that the directrix is going to be 2 away, the focus is 2 away, and the directrix is 2 away. They're always the same distance. So the focus, we know, is at 1, 5. The parabola is going to look something like this. It's opening to the left. And then we can put our directrix in. Just put that this line. So we're going to have to go over 2 more to get the directrix line because, like I said, it's the same distance here as it is here. So here was the focus. Here is the vertex. And here is the directrix. Okay. So now let's go back to this equation. Okay, so part C, the axis of symmetry. So the axis of symmetry, if you can see, it goes along right here. Symmetrical on both sides. Not exactly in my drawing, I'm sorry, it's not drawn to scale, quote. But that is the axis of symmetry. So the equation of that line is y equals 5. Now D, the directrix, we already found that. We plotted it on the graph. That is at 1, 2, 3, 4, 5, and it's going up and down. So it's at x equals 5. E, the length of the focal chord. So let's do that. So that is the length here. The focal chord length is given here. So E, that is 8, given by that. The focal chord is equal to 4p, p being the distance of the focus from the vertex, as well as the directrix from the vertex. But altogether, before you solve, I can actually say focal chord equals the 4p value. And it's the absolute value, it's positive, as we can't have a negative distance here. All right, so that's all that's required for number 35.